Performance, safety and retained value have long been the pillars of the design philosophy of Subaru, and today we're going to test the safety part of that equation by crashing this new 4th generation Outback in a crash test to measure the level of occupant protection that this new car affords. And that's important because in a crash test, and particularly in a frontal crash test as we're doing today, it's a 40% offset test at 64 kilometres per hour, which basically represents a real-world situation where two cars are coming together sort of in an offset scenario with a closing speed of about 100 kilometres per hour. So it's a significant impact force, and we need to absorb the energy of that crash. All Subaru vehicles have the highest level of safety possible. We're always trying to push the envelope to make the next generation car just that little bit better. One of the new things on this car is called the cradle frame, which is a fairly technical expression, but this is the mechanism by which the engine and transmission assembly is mounted to the body of the vehicle. This new cradle frame enables the engine and transmission assembly to move down and underneath the body of the vehicle, much lower than the previous vehicles, and therefore we provide a much larger area of the vehicle, the chassis of the vehicle, to absorb and crumple. So crashes at higher speeds, which do happen in the real world, are better able to absorb the energy in this new design. Another new thing that we haven't had before on this new Outback is what's known as a knee airbag to protect the knees of the driver. And what happens in an accident is the actual driver moves forward towards the dash of the car. These airbags deploy in that area to absorb the contact between the leg or the knee of the driver and the dash of the vehicle. We did have protection on the old cars, but we've just taken that additional step forward to give even more protection. Particularly important in the real world where, sometimes the speed of impact are higher than what we've experienced in these tests. Another aspect of improved safety that we provided in the new generation Outback and Liberty actually is an electronic handbrake. Now, previously the handbrake, as we all know, was a mechanical device beside the driver that we have to lift up to apply the handbrake. So in a side impact, what happens is the driver is pushed towards this handbrake, and impact in the handbrake can cause injury to the occupant. So for a number of reasons now, that's one of them, we've removed that handbrake and provide an electronic mechanism to pulling the handbrake on. Driving confidence is particularly important when you get in the car and you drive, particularly if you've got your children, your family in the car. You need to be confident that this car is going to protect you. I mean, obviously you need to be careful when you're driving and mindful of the road conditions. And there's a couple of things we do to help that confidence. First of all, we provide what we call collision avoidance technology, which is all about the ability to avoid the accident in the first place. So things like symmetrical all-wheel drive that provides us balance and control, and then we move into the electronics, the VDC stability control systems that help the driver to avoid the accident in the first place. If all of that fails, then collision protection comes into play, and that's what we're testing today. We're actually testing the level of collision protection that we're going to provide our owners by putting this car through a crash test scenario. Okay, now the test is completed. We have our final result here. This is the scene of the impact. Over here we've got the crash barrier. This blue section in the front here is a honeycomb material which replicates that other car that's coming towards us on the highway. We've impacted a 40% offset, so you can see that not all of the other car has been impacted, only on one side. And similarly with our car, this is the area of impact in this area here. It's only on one side of the car, so that's why we call it a 40% offset test. And you can see, if you look closely here, this is the chassis rail. This is part here, protruding forward, and this is designed to engage with the other car or obstacle that we hit when we were in an accident. You can quite clearly see over this side that chassis rail, which was out here, the same dimension as this one, has now moved backwards as it engaged with the crash barrier or the other car. And that's moved backwards as it has absorbed the energy of impact. The new thing on Liberty and Outback is this section just here.
which I talked about before. This is the cradle frame, and it's designed, as with the chassis rail, to engage with the other car, in this case the crash barrier, to move again backwards, but it's also designed to bend in the centre, so that the engine transmission moves down and back underneath the passenger safety cell. We're looking to protect the occupants by not allowing the engine and transmission to go into that area where the passengers are sitting. So you can see here that it has moved down, and it's allowed the whole frame, the engine here, to move back further than it would normally do because of this new design. So once that happens, the energy absorbed here, there's still some remaining energy which flows up through the frame of the car. So going up through this part of the frame here, we can see that the windscreen is shattered as a result of that. We can also see energy flowing down through the subframe of the car here. And if we look closely up the top of the chassis rail in this area here, we can see a little crease here in the roof of the car, and this is an indication of that energy flow through the body of the vehicle. We've got airbags, as you can see, to provide additional protection. This is the curtain airbag. So this is obviously designed to protect the head from hitting the side of the vehicle. Similarly with this one here, this is the side airbag. And this airbag is designed to protect the body, obviously, of the occupant in the front. The main airbags for frontal, so they're designed to deploy at the right moment to cushion the forward momentum of the driver, and it's critical the actual timing of the deployment of the airbag and the forward movement of the driver's head. If we meet that timing correctly, then the airbag is fully deployed, and in the back of the airbag, I can find them, there's some holes in behind here to allow the air to come out and deflate as the head moves forward. So it's like a cushioning of that forward movement of the driver's head. Obviously the objective is to stop the driver hitting the steering wheel or any part of the dash, and the same on the passenger side. Down the bottom here is a new addition. This is what we call the knee airbag. And this knee airbag, the idea again is to prevent the knee here or the leg down here from impacting this hard area of the dash or even the steering column up here if they move upwards. So this is a new addition, the knee airbag. Okay, so that's basically the test completed. We're not sure yet of the final result, but on the whole we think it's a very good result. It's just one part of the overall test. There's 3 tests in all. This is just one of them. But looking at the structure of the car, the way it's performed, we think it's a good result. We need to wait, obviously, for the final test result to come through and see our final score, but we're still confident of getting our 5 stars.